All right, so what we've been doing so far is talking about trig functions and the unit circle related to radians. And what we want to do today is relate that to the concept of degrees. And now, radians and degrees are equivalent to each other, and we just need another relationship that translates between the two, and then we can just treat any degree function or degree question just like a radian question. And so when we're doing this, what we want to do is we want to relate everything to the unit circle. If you have a good grasp of the unit circle, just like anything else, then you're going to be really strong trig student. And so we want to try to relate everything back to the unit circle. And the difference between a radian and a degree is what part of the unit circle we're talking about. So that's what's being shown in this picture right here. So you can see that radians, so first of all, this is the unit circle, right? This is the unit circle being shown here. We can see it's the unit circle because it's a circle and it's got a radius 1, right? Now, this slice that's being cut out in the circle is showing us both a degree measurement and a radian measurement. Now, the radian measurement is what we're already familiar with, right? That's walking along on the outside of the unit circle somewhere. And what we've been talking about so far is you end up with some xy value when you walk along on the outside of the unit circle, right? So the outside, when you're walking along on the outside of the unit circle, that's what a radian is. What we're doing today is we're translating that to the idea of degrees, which is the measurement on the inside angle right here. And so this is the degree measurement. And you can see that this measurement in degrees corresponds to this measurement in radians. Okay, and so once again, radians is a measurement walking along on the outside of the unit circle, whereas degrees is the measurement on the inside angle that's made when you change your terminal side and you move along on the unit circle there. Let's read this definition here. So if a circle of radius 1 is drawn with the vertex of an angle at its center, then the measurement of its angle in radians, which we abbreviate rad, is the length of the arc, like we just said, all right, the outside of the circle, and that subtends the angle. And so we see that what's being shown in these next two pictures here, we have a positive angle versus a negative angle. And this is just like with radians, right? When we have a positive angle, we think about starting here and going counterclockwise. And so that's what's being shown on this left-hand graph. We have a positive angle, we go counterclockwise. And a negative angle is when we start on the initial side and we go clockwise, right? Just like with radians, it's the same thing with degrees. Okay, so if we have a negative angle, it goes counterclockwise down, and if we have a positive angle, we go counterclockwise up. Now let's relate some common radians to degrees. Now let me just write this down. I usually like to write this information down on the right just in case it's not clear. And so radians is the length of the arc on the unit circle. Okay, just like we just said, it's the length of the outside of the unit circle. That's the arc. And degrees is the measurement of the interior angle. So degrees is the measurement of the angle in the center of the circle. Just wanted to write down in words what we had just described in that picture there, right? Just to drive that home one more time, not to beat a dead horse here, but again, radians is the measurement right here that I'm tracing, right? It's the measurement of the outside of the unit circle, and the corresponding degrees would be the measurement of this angle down here, okay? What I was just about to do was just kind of relate back to some common angles that we're familiar with. And so for one thing, we know that if we walk all the way around the outside of the unit circle, that's 2 pi radians, right? And so 2 pi radians is what we get when we walk all the way around the outside of the unit circle. And if we thought about the interior angle right here, all the way, if we spin this thing all the way around, that would be 360 degrees, right? And we already know that a circle has 360 degrees. And so the big relationship that we want to take away is that 360 degrees is 2 pi radians. Okay, that's sort of the general conversion there. So if we're looking at these 3 pictures here of common radians, let's start with this one. This one's a very familiar one. Pi radians, right? That's starting at the terminal point right here and going halfway around the unit circle on the outside of the unit circle until we get to right here, the point -1, 0. So we know that's pi radians, and we know this is a very common angle, right? The size of this angle right here is 180 degrees. And we could go between those two things, because if 360 degrees is 2 pi radians, if we want a single pi, we would just divide this 2 over to the other side. 360 over 2 is 180, right? And so we can use this conversion to convert these other ones. Let's look at this one. This is another very familiar one. So pi over 2 radians. Pi over 2 radians is starting right here at the terminal, or the initial point, and walking along the outside of the unit circle a quarter of the way around to that point right there, right? We know that that's pi over 2 radians. Now this makes this angle right here, which is a very familiar angle, right? Just take a second and think, what's the degree of that angle? Right, it's a right angle, and so that means it's 90 degrees. And so pi over 2 radians is the same thing as 90 degrees. And again, we could use this relationship to go between the two of them. The other two are a little less obvious. If we want 1 radian, let's say we wanted 1 radian, then using this formula, this is 2 pi radians equals 360, right? And so if we divided both this side by 2 pi, this side would be 1, right? And this side would be 360 over 2 pi. And so this angle right here, I'll write it out here. This angle right here is 360 degrees over 2 pi. And that's a degree measurement. So 360 over 2 pi degrees would be whatever measurement that is. Again, using this relationship. And if we wanted to know what 2 radians is, 2 radians is when we start right here, we walk along the outside of the unit circle, and then we stop right here. 2 pi radians is obviously more than pi over 2, but less than pi, right? Somewhere between those two. And if we use this conversion, we would divide the pi over, right? If we divided pi over to the other side, we'd have 2 radians on this side, and we'd end up with 360 over pi right here. So this angle right here, then, this angle is 360 over pi degrees. And so this is just kind of visualizing some of the degree to radian conversions, but what follows is an actual way to convert them. It's a nice formula that we can use to convert between degrees and radians. And so that's the next thing we want to look at, is how we actually go about converting them in practice. And so we've already laid the groundwork for this blue box here, but let's read what I wrote here. Since a complete revolution around a circle is 360 degrees, which is in radians 2 pi, we already wrote that down, 360 degrees is 2 pi, the following relationship exists. So we get this relationship. So 180 degrees is pi radians. That's what we just saw right here, right? 1 radian is 180 degrees over pi. That's this one right here. And 1 degree is pi over 180. And so we didn't see a picture of that one, but that's just another version of this. What you really want to take away from this box is, what's in number 1 and number 2 here. This tells us if we want to convert from degrees to radians, we multiply by pi over 180. If we want to convert radians to degrees, we multiply by 180 over pi. And so they're inverses of each other. And one way to think about that is, if you multiply by this first one, if we want to go from degrees to radians, we want to cancel out the degrees and give a radians. And so when we divide by 180 degrees, see that there's a degree sign right there? It'll cancel out the degree, and we give it a pi, which will give it a radian, right? And so on these problems where we want to convert from degrees to radians, we're going to multiply by pi over 180. If we want to convert from radians to degrees, like these, Then we're going to multiply by 180 over pi, because when we multiply by 1 over pi, it'll cancel out the pi, and then we'll give it a degree. Right, and we'll see that in just a second. So let's do one at a time. I'll probably do one of each, and then just ask you to try one of each. Right? And please actually try it. I'm going to pause. I'll take a few minutes and let you try that, and come back and see how you did. This is a really important part of this process. So please, I hope you do that. All right, so let's do this first one. Whoops, excuse me. Let's do this 54 degrees. So we're going to convert this measurement in angles, this angle degree in degrees to an angle in radians. And so this is this first multiplication problem. So we multiply by pi over 180. And so what we do is we take 54, and we multiply it by pi radians over 180 degrees. And you can see that the degrees cancel. See how there's a degree in the bottom and a degree here? Those units end up canceling. And then we give it a pi and a radian. And so this will end up being, and then of course we can simplify 54 and 180, right? So 54 and 180 are both divisible by 8, for example. So this could simplify into 6 pi radians over 20. And now those two are both divisible by 2. And so this could simplify into 3 pi over 10 radians. But again, notice how, they're inverses of each other, right? Which formula do you use? Pi over 180 or 180 over pi? The way to remember that is if you have a degree and you want to end up with a radian, you want to end up canceling those two things out and giving it a radian. And that's exactly what we did here. And so let's use that same logic on this one down here, this 11/3 pi. So let's convert 11/3 pi from a radian measurement to a degree measurement. And so from radians to degrees, we multiply by 180 over pi. And so we take this problem, we multiply it by 180 degrees over pi radians. You can see that the pi radians are going to cancel. See that? The pi's cancel out. And then we're going to end up with a degree, right? So 3 goes into 180 60 times. And so this is really the same thing as 11 times 60 degrees. And 11 times 60 is 660 degrees. But again, we wanted to cancel out the pi and end up with a degree, and this form did that. It canceled out the pi and gave us a degree. So give those other two a try, right? Translate this one from radians into degrees, and then translate this one in from degrees into radians, right? I will pause for a few minutes and let you give that a try, and then I'll come back and write the solution down. Just in case you're stuck, right, on this one you want to be multiplying by 180 degrees over pi radians, and on this one you want to be multiplying by pi radians over 180 degrees. All right, please make sure you're trying this. This is an important part of the learning process. Don't forget. I'll be back in just 1 minute. All right, I'm going to go through these answers now. So remember in this first one, when we're changing minus 300 degrees into radians, remember, the way to remember that is we want to cancel out that degree sign and we want to end up with a radian. And so when you divide by 180 degrees, the degrees end up canceling and you'll end up with a radian afterwards, right? And so that's the way you want to think about, that's a good way to remember these formulas, is what I'm trying to say here. Okay, so when you do this one, we end up with minus 300 pi radians over 180. And this can be simplified more, right? For one thing, they're both divisible by 10. And so we could write this as minus 30 over 18 pi radians. And then they're both divisible by, let's say, 6. And so this is minus 5 pi radians over 3. Or minus 5/3 pi. Or 5 pi, minus 5 pi over 3 radians, right? However you want to say that, those are all correct ways to say that. But the important thing is this is the, oops, I didn't realize I had a page. This is the radian version of minus 300 degrees. And notice how they're both negative, right? So this one goes down, this goes counterclockwise, and this one will also go counterclockwise. So that matches up. With the other ones, we want to end up, we're converting from radians to degrees, and so we want to cancel out the pi, which is why we want to divide by it. And so that'll cancel out the pi and that degree, that unit, and we'll end up with degrees because we have 180 degrees. And so just to simplify this a little bit, if we wanted to think about that, 2 goes into 180 90 times, and this is minus 3 times 90 degrees. And minus 3 times 90 is minus 270 degrees. So minus 270 is the same thing as minus 3 pi over 2 radians. Okay. This is really important. So whenever we want to think about, if you're interested in evaluating a trig function at a degree measurement, we can just relate it to a radian and then think about it in radians, or vice versa, depending on what type of problem we're looking at. But this is the way we go between the two, degrees and radians, and we'll look at this a little bit later as we move further through the trig material. The other thing we're going to look at today, the last thing we'll look at, is the second page, which is, learning the word coterminal and how we find coterminal sides. And so we say that two angles in standard position are coterminal if their sides coincide. And so, in other words, for example, 2 pi and 4 pi are coterminal. Because if we look at a unit circle, they both end up at the same place, right? 2 pi is going all the way around the unit circle once and stopping right here. That's what 2 pi would be, right? And 4 pi would be going all the way around the unit circle 2 times, and also stopping in that same place. And so that's the same thing as 2 pi. And so that's what this is all about. It's realizing that you can get to the same place on the unit circle in more than one way, and in infinitely many ways, really. And so we're going to practice doing it given a radian measurement and a degree measurement. Okay, and so if we're given a radian measurement, we can figure out other positive or negative angles that are coterminal by adding or subtracting measurements of 2 pi, because that's just going to send you all the way around the unit circle and back to that same place. And if we're doing it with degrees, then we add or subtract 360 degrees for that same reason. If we add 360 degrees to an angle, it just sends us all the way around the unit circle and back to that same place, just like this. And so let's do this one first. 11 pi over 6. Let's find some positive and negative coterminal angles. And so what we're going to do, well, let's first of all note where 11 pi over 6 is, right? Let me draw that out. So 11 pi over 6, if we're looking at the unit circle, 11 pi over 6 is 11 steps of pi over 6. And so that would take us, and it's a positive version, right? So we go counterclockwise, 11 steps of pi over 6, and that would put us down here, 1 step away from the edge, from the x-axis, right? So this is 11 pi over 6 right here. If we want to find other angles that are coterminal to this, 11 pi over 6, we can just add 2 pi every time. And so one thing I'll just note, since we're going to, what we're going to do here is we're going to take 11 pi over 6, and we want to add 2 pi to it. Right, this is what we're going to do. And if we want to do that, we need to have we need to find a common denominator, right? This is like 2 over 1 pi. And so let me just note, I'll just put the note up here, note 2 pi is the same thing as 12 pi over 6. And so this, instead of adding 2 pi, we're going to add 12 pi over 6 because that's going to give us a common denominator, right? So this is the same thing as 11 pi over 6 plus 12 pi over 6. I'm just going to pause for a second and make sure that makes sense. I feel like people get confused with this sometimes. All I did is I wanted to find a coterminal angle, so I added 2 pi, and then 2 pi, if I want to have a common denominator of 6, this is the common denominator of 6, so it's 12 pi over 6. Okay? And so when I do this addition, this ends up being 33 pi over 6. I'm sorry, 23 pi over 6. And so this is a coterminal angle to 11 pi over 6. So this point right here is not only 11 pi over 6, it's also 23 pi over 6. Let's add another 2 pi. Let's add 2 pi to this 23 pi over 6. Since that's both of those, let's add it to this one now. So let's do 23 pi over 6 plus 2 pi, which is 12 pi over 6, right? Again, just to be clear about that, I'm just adding 2 pi. That just equals 2 pi. And so I'm going all the way around the unit circle again. So 23 plus 12 is 35 pi over 6. And so this is also coterminal. And so this is another version that will also put us on that exact same spot. And so not only can we add 2 pi, we can also subtract 2 pi, because adding 2 pi is like starting here and going around counterclockwise, right? I'll say that again. Watch what I'm pointing at. Adding 2 pi is starting right here and going all the way around counterclockwise. If we subtract 2 pi, it's like starting at that point and going around the other way, clockwise. And so we can find other coterminal angles by taking the one we started on, 11 pi over 6, and subtracting 2 pi. So I'll subtract 12 pi over 6 now. Again, remember this just equals 2 pi. 11 minus 12 is minus 1. And so this is also a coterminal angle. So I'll put this one up here too, or I'm going to write this one up here too. This is also minus pi over 6. And I'll just do it one more time just to be clear. So we could take minus pi over 6 and subtract 2 pi again, and we'd get minus 13 pi over 6. And so this is another coterminal angle. So all these angles, all these radian degree measurements will put us on that exact same spot in the unit circle, and these are all coterminal angles. And we could keep doing this forever, right? So this is like etc. We could keep going on forever and ever. And I just want to be clear by writing all these are coterminal. And again, they're coterminal because they all put you on the exact same spot on the unit circle. I would like to ask you to do the same thing with minus 45 degrees, and I'll set it up a little bit here. So minus 45 degrees, if we look at the unit circle, minus 45, it's negative for one thing, right? And so minus 45 means we start right here, and we go halfway to minus 90. Minus 90 would be going down to here. And so halfway to minus 90 is right here. And all these degree measurements are also on the unit circle. That's part of your homework or your note packet too. So if you want to double check your note packet and look at your unit circle handout, you'll notice that every time there's a degree measurement or a radian measurement, there's a corresponding degree measurement. So keep that in mind. Right. So this is minus 45 right here. Again, we started at the initial point and we went down 45 degrees, which is halfway to 90 degrees. The other way to think about that is it's the same thing as minus pi over 4. Okay? And if we want to find some coterminal angles to minus 45 degrees, we would just add or subtract values of 360. And so we could take minus 45 degrees and add 360 to get a coterminal angle. If we added those two, that would be 315 degrees. And so 315 degrees is also coterminal. Let's take 315 degrees and also add 360. So that's just going around the unit circle another time. When we add those two together, we get 675. So 675 is also a coterminal angle. Right, so we found two coterminal angles by adding 360. But just like on the last one, right, in the last one we could subtract 2 pi, and so let's subtract 360 on this one. And again, remember, we're adding and subtracting 360 because 360 takes you all the way around the unit circle. It's like starting right here and going all the way around. And when we subtract 360, so if we do like minus 45 minus 360, that's starting at 45 and going all the way around the unit circle the other way. Right? It's going all the way around the unit circle clockwise instead of counterclockwise. And so if we subtract, we get minus 405. So this is another coterminal angle, minus 405. And I'll just do one more. Minus 405 minus 360. That's minus 765. And so that's another coterminal angle. And so all these are also all coterminal. All of these angles are also coterminal with each other because they all put you on that same very spot on the unit circle. Now this is pretty important stuff. It's not groundbreaking and it's not terribly, I don't think, difficult conceptually, but you do want to work on it a little bit because we want to use this information in later material when we're dealing with degrees, and we want to be able to recognize coterminal angles when they're, when 2 points end up putting you on the same spot on the unit circle.